So this talk is about boosting your app's emotional intelligence. 3 strategies to make your apps feel all the feels, all of them, okay? And I apologize for all the Bitmoji. I went a little overboard, but I like my Bitmoji, so I use her a lot. So this is another thing about having teenage kids. So who am I? My name is Jen Looper. I'm a senior developer advocate at Progress, like my colleague in the back, Alyssa. There's several Progress people here. Hey, Alyssa. And Sebastian, who was just speaking. So we are all at Progress. I'm a developer advocate for NativeScript. Alyssa's developer advocate for Kendo. And Sebastian's also here for NativeScript. So if you have any mobile app questions, you know who to talk to. So we will sort you out. Oh, and I'm coming from Boston. That's where I'm calling home nowadays. So let's talk a little bit about mobile apps. How many mobile developers I got in here? Okay. By the end, everyone's hand's going to be, yes, queen, NativeScript, that's awesome. Okay, well, anyway, so we're going to talk about mobile apps, but very specifically, we're going to talk about NativeScript apps, because that's what I'm actually paid to do. So that's good fun. So it's a good thing I have this slide, because I'm thinking maybe several people aren't familiar with NativeScript. What is NativeScript? Well, it's an open source framework for building truly native mobile apps with JavaScript. So you're going to use your web skills like TypeScript, Angular, and CSS. And also, I have to adjust this sentence because we now have a wonderful implementation for Vue.js. How many Vue leavers have I got in here? Yes. OK. Well, we have a wonderful implementation of NativeScript for Vue. It's really, really nice. And anyway, with these skills, you're going to get native UI and native performance on iOS and Android. So that's kind of exciting. Just think about like the kind of black magic it takes to be able to write in JavaScript and compile for a native mobile app. That's really cool. So this is another controversial slide because I say that NativeScript is, in my opinion, the best tool for cross-platform native app development. Now, there are people who are also doing this kind of thing, people like Ionic, of course. I'm thinking also Titanium. I think Axway is here, and I think they are affiliated with Titanium, if I'm correct. But there's this kind of idea of JavaScript to native compilation, and that's the horse we're riding. So it's kind of a cutting-edge, new, and cool technology. So what does NativeScript offer? It gives you this rich and animated, no-compromise native UI with this possibility of shared code, which Sebastian was just talking about. So if you go to the app stores on Google Play or the iOS App Store, you can download an app called Examples NativeScript. And you can kind of get a feel for the way NativeScript feels. And it's kind of a neat app because there's a little tab, and it'll show you the code that's running behind the scenes. So it's kind of a nice little way to look at what you have to write in order to make this kind of interface. So it's kind of neat. And when I'm working booth, which I do a lot, AKA therapy sessions for developers, people will come up to the booth and they'll be frustrated. They'll say, the front-end ecosystem is a nightmare already, and what did you do? You made us another thing, another script I have to learn. Why do you do such things? Well, NativeScript is not, a new kind of scripting language. It's just JavaScript. So like everything else, it's just JavaScript. And if you know JavaScript, you know NativeScript. So that's really cool. And you're going to be able to use JavaScript, CSS3. You can import NPM packages, or you can write your own plugins using these NPM packages so that they'll work cross-platform. You can use Angular if you like, or not. You can use Sass or not. That's the Webpack logo, so you're definitely going to be using Webpack if you're using especially Angular, but we also use it in Vue, of course. If you want to use TypeScript, you can use TypeScript. And then we have, like I said, this new and cool implementation for Vue.js, which is actually a community-driven program that we've just kind of gotten started, and it's really exciting. So basically with something like React Native, you're going to be always using React. With NativeScript, you can use Angular or Vue or no framework at all to build your mobile app. So that's really a nice kind of differentiator between those two ecosystems. So I know that especially in the Java community, there's this idea that write once, run everywhere is kind of trigger language, and everyone gets a little upset when you say such a thing. But it is actually something that we're able to offer. We have these about 75 NativeScript modules. We call these modules. So this is an example of using the NativeScript file module so that you don't have to write this snippet of of Android code of Java or this bit of Objective-C. So you're just using the file system module to kind of obfuscate that code away from yourself so you don't have to bother writing the same thing twice to get the kind of cross-platform performance that you're wanting. So once you're done with your scripting, you're going to be writing the UI with XML. And I know XML is another trigger word, and people get a little upset when we say that you're going to need to be using XML, but it feels a lot like HTML, actually. And the cool thing is with the NativeScript modules, you just write something like switch and then close your tag switch. And then NativeScript will build for you a native iOS and a native Android switch on the front end. So it's a really kind of clean and neat way of writing cross-platform with JavaScript, XML, CSS. And like I said, you can build plugins with native libraries. You can import something out of Android Arsenal. You can use CocoaPods, NPM packages like Moment. And you can get this kind of extra functionality that you're always going to need in a mobile app. Once you get past the basic functionality, you're going to be needing to use CocoaPods or something special, like if you need touch functionality or something like that. Or you can go ahead and visit market.nativescript.org, which is our marketplace. And this has, I think, 600 plugins, some large number like that, of mostly community built, but some are officially supported plugins. The ones with the little green check are verified plugins, so either they're built by us or they're verified as being high quality by us, something like the Firebase plugin or the Kinvey NativeScript SDK. So these are all plugins that are safe and good to use. This definitely needs to be updated, this slide. It's a picture of our community Slack channel, and our community is really fun and cool. We actually have not 4,800, we have 6,300 people on the NativeScript Slack at this point. It's a little bit wild, but it's a lot of fun, and it's quite kind. It's a good place to be. So the most fun room within the Slack channel is actually the view room, in my opinion. So we have a good time, and it's a good way to interface with a very fun community. So it's a lot of blah, blah, blah from me. This is not a product pitch. I do want to kind of give you an idea of the tools that I use and the tools that I think that you might want to try to make such a mobile app. But actually, this talk is about how to stop your apps, like stop your apps from being stupid and boring. So I found this beautiful example of a gray and white and black app. And all it is a master detail screen with a couple of icons. It's really not very awe-inspiring. But a lot of apps simply are that. They're just a master and detail screen. And you can do so much more by adding little extra bits. And this talk is actually giving you 3 strategies to move past that kind of boring piece and move towards something a little bit more interesting. So you can fix that by trying an IoT integration. How many hardware hackers have I got in here? It's very, very fun. We're gonna play a little bit in a minute. You could try an IoT integration. I'm going to demo 2 machine learning APIs, which are very cool. And we're going to talk a little bit about what's coming next in the field of mobile development and machine learning on device, which is something that I get really excited about. So how can we make our apps smarter? And when I say smart, I mean more human, more empathetic, more helpful. Not just another gray and black master detail screen, but something really interesting and something that actually helps people make their lives just a little more interesting. Well, to that end, I built something. I built an app called QuickNoms, and it looks like this on the web. This is a basic Angular app built with the CLI. And it's just a recipe app. So in theory, it's just another master detail app, right? You have categories of recipes, your meat recipes, and then you click on the barbecue icon, you get your barbecue beef recipe. Very, very basic. But recipe apps in particular are apps that you can really have a lot of fun with. So this is what I built. I built an app called QuickNoms, and the premise behind QuickNoms is that you have 5 ingredients, 15 minutes, minimal setup, and then you can have dinner on the table. So the story behind QuickNoms is that I sent my daughter to college recently to Vancouver. I live in Boston, she's in Vancouver. It's quite a hike. And as she's walking out the door, I'm realizing I forgot to teach this child how to cook. 20 years later, you realize, oh dear, something's lacking. And so instead of actually teaching her how to cook, I built her an app. And people from all over the community are sending me their student recipes. It's really cute. I had a kid in India, one of our terrific champions in India, who sent me a magi recipe, which is like ramen. So it's brilliant. It's very specific. You take the thing still in its package and you break it into 4 pieces. It's very important. Dump it in a bowl, pour hot water over it, put a book on top of it to make it steam. It's very critical. And then you eat it with ketchup. So this is his recipe. This is the ultimate quick nom recipe, student recipe. And then I just had a guy in Australia just the other day send me, let's see if I can find it, this meat recipe. Sausage on bread. I love this. Isn't it brilliant? Sausage on bread. It's apparently every Aussie is like just dies for this. It's hysterical. And especially with the white bread. Doesn't it look great? So, and even the description is great. Preheat fry pan or BBQ and add a lick of oil. Add a lick of oil. I just love it. It's so cute. But he did a great job. So this is the kind of stuff that is in this extremely useful recipe archive. So that's the web app. I have community people submitting into the web app, and then they can either use the recipe on the web, or if you're on your iPhone in a panic, you can just be in the kitchen and you have your mobile app to help you out. So consuming the data on web and mobile. So to do this, I used Angular, NativeScript, and Firebase, and I built this app. Now on mobile, it looks like this, and I'll demo it in a little bit. But what it is it's just, you saw the web app. This is kind of similar on mobile. The interface I borrowed from an app called Forks Over Knives. I don't know if you've seen this. It's a really nice vegetarian app. And I wanted to see how far I could push I like to copy user interfaces sometimes just to see how far I can push NativeScript. And it actually was pretty straightforward to do. So again, master detail, you pick your category, you pick your type, your meat recipe or whatever, and then you just click into it and you get this split screen. So there's a little note at the top, and then ingredients, tools, and procedure. So it's a little tab navigation. And then there's a button that can be a text-to-speech integration, so it'll speak out the recipe. So Siri will help you cook, which is good. So submit your recipes on the web and consume them on the mobile app. So another thing that this mobile app features is the use of the remote config marquee, the remote config functionality in Firebase, which I use within this marquee at the top. So whenever a new recipe comes in, I can go into the backend in Firebase and send a little sort of message. So it acts like a little notification marquee, and it appears instantly. You can use this to switch parts of your UI, and Firebase will help you kind of get that done. It's not as great as something like Code Push that I think Microsoft supports, but it'll get you at least some kind of like instant notifications without having to deal with push or any of that stuff. So remote config is useful that way. And I also included the Algolia search, which came in handy. So anybody using Algolia? Wonderful French company. Fantastic company. I strongly recommend. So we have a NativeScript plugin for Algolia that's really terrific. So you can just search any piece of the text and then the recipes will come right up. So the goal of this talk and of building this app and of enhancing the app was to make QuickNoms a little bit more empathetic, make it a little more helpful on mobile. Web, it's basically just inputting recipes and looking at them, but on mobile, we can do some really interesting things. So we're going to move from a simple master detail app to, can I help you? How can I be of service? How can I be useful? So the first task I set myself is to make this app a little bit sensitive. And this is a little bit silly because, if you're in a room that's kind of cold like this, you're not really in the mood for ice cream. This intrinsically. But the joke is basically that, we wouldn't know that unless we had an app to tell us the temperature of the room and to suggest a recipe, So what I'm doing is I'm using a little sensor here. It's testing the room temperature. And then I'm plugging it into my Algolia search plugin that I handily had integrated already, and it'll pull me recipes that it thinks will make me feel good, feel more comfortable. So if it's, as we say, hotter than hell, then it'll suggest something nice and cold and refreshing. And if it's a very cold room, you're going to get something like, barbecued brisket or something nice to eat. So let's see how this all works. So the first thing to do is to add a sensor. And this is the sensor I use. I tend to gravitate always towards Particle Photons. Very, very cool company. They are basically Arduinos, but they're Wi-Fi enabled. So there's a little Wi-Fi chip on here. And fortunately, in this conference, it's working brilliantly, so we're going to have some fun. You never know, with the Wi-Fi shaky, you don't know what's going to happen. So then you have to do a pinout, and you create your device. So you take your photon, you slap it into a little breadboard. The breadboard's like this. You do a bit of wiring, and you add a temperature sensor, which is this little prong right here. You can come see it a little bit closer if you'd like to later. And the whole thing is about 25 bucks. And then you have to do a couple of software integrations to make everything work nicely. And this is real fuzzy, but it's basically, I think, C# code. And just like what you would do for an Arduino, you would do for your photon. So what you're going to do is flash code to your photon. And then what it's going to do is read the temperature of the room every 10 seconds and write data into the particle cloud. So the nice thing about Particle, about this whole device, is it comes with a cloud service, and it comes with several nice IDEs and build tools that will kind of help you move your code around. The great thing about it being Wi-Fi enabled, unlike an Arduino, is that you can flash code over the wires to it. So you don't have to unplug the thing, dismantle it, plug it in, flash code to it, and then reinstall. So this is just a really super useful device. You can just constantly be doing little updates. It's very helpful. So this is reading the temperature and writing into the cloud. So the data is being written into the particle cloud, and then somehow I need to get my data into Firebase, because that's where all of my data is coming into the app. Unfortunately, you cannot write from your hardware device straight into Firebase. That's a bit of a limitation, but I can read from Particle Cloud into Firebase. So that works pretty well. So all you have to do is do a webhook, and you can be basically, watching for data coming out of your device and writing it into Firebase every 10 seconds or so. So it ends up looking like this. I have a collection in Firebase called temperatures, and I save the device ID so I know which device it's talking to. And then this temperature is getting overwritten. And then my mobile app is going to consume that data, and we'll see if it's going to work in a second. Hopefully my hands are not too cold. So the app is going to consume data, and it's going to react, and it's going to select recipes that I've tagged in the back end as hot recipes or cold recipes, recipes that are good for hot weather or good for cold weather. And then we have some Angular code here. So all we're doing is subscribing to the temperature and saving it into Firebase, or save it into Firebase and reading it into the observable. Now, I know this idea seems really crazy because I'm saying basically I deployed a mobile app and I expect everyone to have one of these devices attached somehow to their room. That's crazy, but you could scale the idea if you had a Nest. Anybody hacked a Nest recently, a Google Nest? It's their smart thermostat. I'm pretty excited because we're moving houses pretty soon, and I'm going to be inheriting a Honeywell thermostat. So I don't know how much I can hack on that thing, but I'm pretty excited. I hope the house doesn't explode, so we'll find out. We'll find out the hard way. Okay, so let's demo. So I'm going to go ahead and show this mobile app on my QuickTime. So, recording. All right, there's my iPhone. Okay, and here is QuickNoms, and always with the iTunes. Go away. Okay, so what I'm going to do is open up my temperature search right here. So it's in the side drawer. I'm just going to open it up here. And right now it looks like this. It says it's 75. Well, I'm sorry, I didn't translate to Celsius, but 75 is basically room temperature. I'm going to attempt to warm this up with my hand, and every 10 seconds it should get a little bit warmer. So watch the temperature. My hands are cold. There it is, 77. Let's see if I can make it hotter. .78. So it's fun to try to put ice on it, but I'm always worried about shorting the thing out. So let's see what recipes are suggested. Oops, right here. There it goes down again. It's a great time to have some ice cream because it feels kind of warm in here. Ambrosia. This is an old family recipe. There's so much sugar in this, you cannot shake a stick at it. It's so funny. It's all marshmallows and coconut. It's the worst thing in the world. But anyway, so a good recipe for hot weather. Banana split. Delicious. So, oh, and then there's a gradient here. So if it's cold, it turns kind of blue. So it just gives you a visual cue of how hot the room is, as if you couldn't tell already. You have to have a visual cue, right? Okay. So, kind of fun ways to integrate sensors with your mobile apps. It really works pretty well. Okay, now let's get, speaking of meat recipes, let's get to the meat of all this stuff. I want to talk about adding some machine learning to your mobile apps. This is very, very fun, very, very fun. How many data scientists I have in here? Very good. Are you using TensorFlow? Very fun. Okay, cool. So machine learning in mobile. Machine learning in mobile is exciting. This is the big frontier. Just think of this thing that every single one of us has one of these things, or at least one. And we carry it around, and it's watching us. And we're getting all this sensing data coming through, picking up audio. We've already fed tons of personal data into it. So this is like the ultimate machine learning device. The amount of data we feed into these is actually a little scary. But as we know, machine learning is easy. Very easy to take care of. It's actually not that easy. This is a slide from Andrew Ng's Coursera course, which if you're at all interested in learning the basics of machine learning, I suggest you take. It's free, it's hard, and it's useful. So if you can power through it, it's worthwhile. He's at, I think he's at Stanford. Yeah, he's at Stanford. But what is machine learning? What are we talking about here? Very cute slide. The little adorable computers. They're all learning. Well, it's been said that machine learning is a way to give computers the ability to learn without being explicitly programmed. That's a little bit vague and fluffy. So a better description is that machine learning, a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks T, as measured in P, improves with experience E, which is quite the earful and the eyeful and the mouthful, but the big idea here is the word improve. So what you want is the algorithm to be feeding you more and more accuracy according to the data that you're getting. So you're going to watch the learning curve go up and then flatten out as it basically improves and gets as good as it's going to get in analyzing the tasks you've set it to do. So this is a little intimidating, certainly for me. I'm not a data scientist, but I really want to be able to use this kind of new and exciting field in my mobile apps. So let's talk about how we can do that. I think it's important to have some kind of basic idea of what's going on with machine learning. So I made a little list here of what's going on behind the scenes with machine learning. So supervised learning is the most basic fashion of machine learning. There's a couple other types, but what you're going to be doing is gathering a lot of data, a lot of images, a lot of sounds, as much as you can. And then you divide that data into a training set and a test set. And the training set is categorized. It's sorted by hand or by machine. And then the test set is uncategorized. So you're going to use this algorithm to train a model with the training set by pairing your input with the expected output. And you're using the test set to test the accuracy of the training. So train, test, test, and watch the accuracy of your algorithm be measured according to the accuracy of the output. And then you keep going and going and going until you get the accuracy that you're looking for. Some examples of machine learning in the wild. There's a lot of it. It's kind of touching our lives without us even realizing it. It's very exciting. So good uses of machine learning would be something like Stitch Fix. Any Stitch Fixers in here? Oh, actually, probably not. I don't think they're in the UK. But in America, we have fashion issues, and they need to be fixed by subscription boxes. So it's one of these subscription services, and every month or so, your stylist will send you suggested clothing. This is actually an example of a Stitch Fix. Actually, this is too. I forgot. Anyway, it's not too bad. But what it does is it's a nice combination of using machine learning and human curation in the back. So the way they do it is they use formulas to pick out clothes based on the customer input that you're giving, whether by a Pinterest board that you show them, or a Facebook page that you show them, or specific things. They give you a little quiz to fill out, and you get this information. Then they pair you with a stylist. I am 99% sure that my stylist is human, and her name is Rebecca. And they also have some formulas to calculate the distance of the warehouse to you, so that since I'm in Boston, they're not sending me flip-flops in January, this kind of thing. And then they have algorithms to search and classify clothing trends to recommend, which is kind of neat. So they can say, in Boston, I'm seeing a lot of floral prints, and I'm going to recommend this to you. So there's kind of skimming over the internet, watching for trends. That's a great use of machine learning. It It's not invasive and it doesn't really bother anyone. The end result being that you can walk down Comm Ave in Boston and you can look absolutely fabulous. So very important and strategic uses of machine learning. But there are also some really scary uses of machine learning. I just updated the slide because this second image just came through of what's going on in China, specifically installing a ton of surveillance cameras and getting really good at machine learning powered facial recognition and being able to match those faces to specific IDs. Everyone over the age of 17 in China is in a government database, and then they're able to monitor your emotions, manipulate group emotions, pushing ads at people based on age and gender. We have that plenty in the US, so I'm not calling anyone out on this, but it is annoying as hell. And this business of invisibly tracking location is basically kind of a big nope to me. It's not opt-in, I don't like it, and I would wish that people would kind of stop with this sort of thing, but it is definitely going on. And it gives you an idea of the kind of power that's going on nowadays. But there are also some interesting good and bad, kind of helpful and harmful uses of machine learning that I just wanted to call out. In Boston, we have a very, very large public school system in Boston proper. And the biggest line item in their budget is school busing. It's extremely expensive, millions and millions of dollars. The big yellow school buses that go and pick students up and then schlep them to the schools. So they said, okay, here's a great idea. Let's go talk to MIT, which is right here. And we're gonna ask them to, we're gonna do a hackathon, so they're gonna win a prize. And they're gonna figure out a way to optimize these school bus routes so that we can save some money. Great idea. So they were able to, these kids were able to eliminate 50 routes, combining some, rerouting others. They saved $3 to $5 million. That's very good. Out of 35 million, I think, is the budget. It's not nothing. But unfortunately, because they eliminated routes, they also eliminated jobs. So here's 50 union bus drivers who are looking for work. So I kind of use this as an example of a great idea that I think has repercussions, and I think we need to understand these repercussions and just watch out a little bit what we're doing. If we know there's going to be such a repercussion, if we think far enough ahead, we can mitigate. So something to think about. And as developers, with great power comes great responsibility. We're the ones that are actually going to be doing the grunt work, especially the data science guy over there. So I think it's really important just to kind of think a little down the line of the decisions that you're going to be helping to make. Recently, there was an interview with, I think he was a developer, and he had been tasked with creating an algorithm that would identify potential future gang members by photograph. This is literally the worst idea I've ever heard in terms of racial profiling. And he basically threw up his hands and said, I'm just a developer. That's not a good excuse. That is not okay. So I think this is something that we really need to just pay attention to, because we're the grunts, we're doing the work, But I like to give a round of applause to Microsoft, who is doing really interesting work. They have a very nice snow leopard trust partnership, and they've been installing cameras, not to surveil people, but actually to surveil the snow leopards to see how many are left in the wild. Can you spot the snow leopard in this picture? It's kind of really hidden, but it's a hell of a job with machine learning and image recognition. He's right here. I think he's kind of cute. He's like sniffing at the camera. It's like my cat, Ooh, nice toy. But that's like a really nice use of image recognition, patterns in nature. They also have a program called AI for Earth, which is really neat. They're addressing questions of climate change, watching for patterns in shifting tides, shifting air currents, this kind of thing. Watching for changes in biodiversity by getting a lot of data and figuring out what's going on. Helping with agriculture and water conservation. So I love this idea. I think Microsoft is doing absolutely the right thing. Very, very well executed. So good job, Microsoft. Okay, back to reality, Jen. I get excited about the environmental stuff, especially. So as we know, do-it-yourself machine learning is hard. You need a lot of firepower, a lot of skills, and a lot of data. It's actually the data that's the hardest, just to get this amount of data to get good results. I'm trying to do a demo, and I only have 20 images to analyze, and of course the accuracy is just not going to be that great. You just need a lot of data to get anything meaningful. So it's been suggested that a better way to do all of this is to use a third party. Use pre-trained models, and there's a lot out there at this point that we can use. Models by Clarify and models by the Google Cloud Platform. So these are all pre-analyzed sets of data that we can leverage, that we can use, and they're very well done and very helpful and very easy to implement. So I'm going to do 2 demos for you with my QuickNoms recipe app. One's using Clarify and one's using Google Cloud Vision API, and they're very fun. So anybody using Clarify? New York City company. Miraculously have fended off being acquired. I love them. They're great. They're savage. And they are absolute specialists, absolutely the best in image analysis. They are brilliant. They not only took top prize, they took the top 5 prizes in the 2013 ImageNet Challenge. ImageNet is something they do every year to see who's creating the best image recognition algorithm. And they have terrific techniques, very innovative techniques mathematically in training models to analyze these images. And fortunately for us, they offer pre-trained models. They have the food model, there's a wedding model, there's a not safe for work model, so you can protect your company from random images. Or they're allowing you now to train your own model on their servers, which is kind of neat. I'm guessing that they're going to start charging for that. I'm hoping so, because they need to start charging for something. So the question I posed to my mobile app is to imagine that you're in a restaurant and you're really not quite sure what you're looking at, but it's absolutely delicious, right? So maybe you would be able to take a picture and figure out whether it would qualify as a QuickNom. Ergo, it would be something that you could make at home because you're really not that skilled of a cook, right? So is this dish simple enough to be classified as a QuickNom? In other words, it needs to have 5 ingredients and they need to be discernible. So something like this fancy Sichuan hot Chinese dish going on here is probably not, because it's kind of very composed, it's very crafted and cooked, and there's a lot of stuff going on in there. But a nice little fruit salad like that might actually work. So let's see how to construct this sort of thing in a mobile app. So here's a little bit of Angular code that you need to do. You just take a picture, and then you're telling your camera, send me this picture at 300 by 300 into my device, and we're going to send it over to the Clarify API via a REST API call. It's very simple. So all you have to do is send this base64 picture over to the API with your Clarify auth key, and it's going to return you a response. And the response that it's going to return you is a whole bunch of tags, what it thinks it's looking at. So, and also the certainty that it thinks it is. So it thinks it sees a pear and a peach at 0.6.7% certainty. So it's just going to give you an idea of what it thinks is going on in this recipe. So I kind of made a little rule that if Clarify picks out between 4 and 8 ingredients listed with over 0.899 certainty, it's probably a QuickNom. So let's put this to the test and do a little demo. Okay. All right. Okay, so I'm going to go to QuickNom or not, and I'm going to take a picture of a pretty complicated dish, and let's see what Clarify thinks is going on here. Oh, sorry. You want to see the image. No, not GitHub. There it is. Okay, so this is the phone. Okay, so I'm going to use this photo, and I'm going to make this REST API call. So Clarify is going to get the image, and oh dear, it does not have the qualifications of a QuickNom. Why? Because it thinks it's shrimp, nachos, poutine. How many Quebecois do we have running around? Thinks it's chicken, pizza. It just is not really 100% sure what it's looking at, right? I think it's confused by the tofu. But it's just too much. It's just too much going on here. So let's take a look at this fruit salad and take a picture. All right. So go back to QuickTime, and I'm going to use this photo. Let's see. Oh, it also thinks this is not a QuickNom, really? Why? Oh, it came back thinking it's, oh, it was only certain that it's looking at salad, watermelon, and strawberry. Well, it's incorrect on all of those things, so that's awesome. Well, I got the strawberry. Hey, it's not foolproof. But anyway, it gives you an idea of what the ingredients are. So there we go. You never know what's going to happen with Clarify. All right. So there we go. Okay, a second test that we could do is to take pictures of actual food. So imagine you're standing in front of your refrigerator. You know how you're sitting there and you're just looking, you have no idea what you can make with, you've got a tomato here and an avocado and maybe an onion. Actually, you can make guacamole, that wouldn't be too bad. So, what can I make with certain things that I'm looking at in the grocery store? So with that, I can use the Google Vision API to match images with recipes. So we looked at Clarify. Let's take a look at GCP. Google Cloud Platform basically gives it all to you. It has everything but the kitchen sink going on. Because we've very kindly given it so many photos over the years, it's gotten pretty good at all of the image recognition. So thanks, Google. All of the Google photos have been analyzed. And they offer several services, not just label detection like Clarify. They offer that plus explicit content detection, logo detection, landmark detection. There's a bridge in Portugal that looks an awful lot like the Golden Gate Bridge, and it can tell the difference. That's kind of neat. Face detection. I'm not going to test that because I'm scared of that stuff. Web detection, this I want to try because I think you can make a great fashion app that would allow you to take opt-in pictures of someone's clothes, and then they could search the internet, for the brand. I think that would be very useful. So how would I go about building this sort of thing? Well, again, take a picture at 300 by 300 aspect ratio and process the item as a base 64. Send it over to the Google Vision API with your Google key, and then it'll send you back a certain amount of data. So in this situation, I'm just asking for label detection, and I only want the first label that comes back. So because what it's going to do is it's going to go ahead and match what it thinks it sees with a recipe that it's going to search using Algolia. So there's a lot going on here. So we just take that first label and send it over to Algolia to do the search. So let's just see how it's going to work. And unfortunately, there's a market near here. So I have a banana, I have an apple, and an orange. Let's just see if we can discern what we're looking at. Okay. So if it tells me banana family, I'm going to be very annoyed. But let's see. There is no banana family. Okay, we'll take a photo. I'm going to use that. Yellow. Don't you love machine learning? Isn't it awesome? Let's try. I'm going to flip it over. You never know. Produce. Hey, we're batting 1,000. All right, screw the banana. Let's go. Let's try the apple. Yes, that worked. So that was nice. And the reason it worked, from sad experience, is because it's looking for this particular aspect of the apple. Like if you do it this way, it's a little unclear. So I've had this fail enough on me that I know you're going to take the apple at a certain place. Let's try an orange. I don't actually think I have any orange recipes, but I just want to see if it knows what it's looking at. All right. Oh, it did come back as orange, so that's cool. Okay, sometimes it'll say clementine or mandarin. So you just don't know what Google's going to send back to you, but it would be kind of neat to have this. I think this is actually a more useful sort of demo that you could be running around through the grocery store and taking pictures. So that would be fun. Okay. So looking forward, just a few minutes to look forward. Because what if you want something on your device, happening on your device, and you don't want to make all these expensive REST API calls? At some point, Google's going to start charging me. I do not look forward to this day. But Clarify, I don't even know what their pricing is. I haven't quite figured out how they're making money. But God bless them, they allow me to use this service for free at the moment. But what if you need offline capability? What if you want to keep your data on device? This is important. You want to manage your data and just keep it to yourself. Or if you want to train something really custom, then you might want to use something like some of these new libraries that have come down the pike. One of them is Core ML. It's for iOS. And you're training these models externally, and then you let Core ML process it for your app on device so that you're able to do much quicker analysis of the model on your device without making REST API call back and forth and expecting all the latency that this demo is expecting. So enter the world of TensorFlow Mobile. This is version 1 of what Google was introducing. TensorFlow is Google's library for machine learning. It's the greatest thing since sliced bread. It's very, very cool. I have it on my machine actually, and it makes everything get really hot, so you can actually cook at the same time on your machine. But what is nice about TensorFlow Mobile was it was released initially with support for iOS and Android. So you're not dependent on something like CoreML, which is uniquely for iOS, but they launched this product for both devices, and I really appreciate that. And it's designed for low-end Android, so they're really concerned about keeping the size of it down, making it fast, and making it work on all kinds of machines. So the next generation of machine learning on device, after mobile was introduced, they sort of did a little refactoring, a considerable amount of refactoring on device, and they introduced TensorFlow Lite. So this is the next generation of TensorFlow for mobile, and it is, again, watching out for low latency devices, watching out for the small binary size. So you take a TensorFlow model, you convert it to a TensorFlow Lite format, and then you're able to deploy it onto device and build an app around it. So it's quite brilliant. On iOS, they just announced at the TensorFlow Dev Summit that they are allowing you to take your CoreML stuff and convert it into TensorFlow Lite. That's really, really a huge help. So it features a lot of cool extras. It's using flat buffers, which are a smaller and faster memory-efficient way of handling this analysis. It has a mobile-optimized interpreter. It allows for hardware acceleration, and it's really small. If you don't use a lot of the external libraries, then you can keep it down to just a few KB, which is really nice. And they announced that coming soon for TensorFlow Lite is training on device. So like you're not training on your MacBook Pro or using some external model and then freezing it and then converting it and then using it. You're able to actually train on device. So I'm curious how this is going to work, but I'm kind of excited by the progress that this project has shown. They're doing great. And for those of you who have used the Google Translate app, this is actually using using TensorFlow on device. And what you do is you go into your device and you hop into the TensorFlow, the Google Translate app, and then you download a model. And once you've downloaded that model, like I've downloaded the Chinese model for Chinese translation, I'm able to go ahead and use this offline if I want to. So in Bulgaria, it's extremely useful because I don't understand a word of what I'm seeing when we have to do business trips into Bulgaria, so it's great for reading menus and this sort of thing. So I have a little test for it. My mother-in-law sent me a whole bunch of really cute little riddles that she clipped out of the newspapers for years. I have a huge stack of these. But they're little Chinese riddles about animals. So what I thought is it's kind of fun to try to to test the strength and the power of the Google Translate app, which is using TensorFlow on device with models, and see how it looks. So let's go ahead and try. So it's going to get confused because there is the phonetic transcription, which is called pinyin, on top, and then under it are the characters. So in that situation, what you want to do is take a picture, and it's going to go through, and then you can go with your finger, and it'll give you a little translation. So what animal is called, actually it says meow meow, likes to sleep during the day, I think it sleeps during the night. Oh no, it's active during the night, and the mouse sees it and dies. So what is it? It's a cat. So obviously, let's try another one. I just love the implementation. And you can see the speed, and that it works offline is kind of amazing. So let's try this one. One of the problems is the light's a little bit low. So it'll pick up it should pick up snail immediately. So let's try to get this guy. Try to get all the characters so it'll give me a better translation. There it is. All right. What animal is ugly? It has no feet and no hands. I'm like, the eyes grow overhead. And it walks around, I think it's walking around with its house behind it. I think that's where we're going. That's the direction we're going here. So it is a snail. So very nice implementation. And machine learning on device. You can see no API calls. It's all happening in real time. And it can happen offline. So very cool. I think I'm out of time. I do have one more demo. And this is actually using TensorFlow mobile right on device. And basically, it reads a room. It's been trained on some room in Mountain View. And it's seeing all kinds of things that aren't here. Stretcher. A shoe shop. Look at the shoes. A sea lion. Who's a sea lion? That's terrible. Sliding door. Let's see if I can get one thing accurate here. Where's the cash machine? I want the cash machine. Oh, yeah. I don't think it'll understand television. No, because it's only been trained on like walls and things. Yeah. Oh, gosh. Like demos. It's a bullet train. Oh, because it thinks it's long, so like it's an airship. Oh, my God. We're all going to go. But anyway, yeah, machine learning on device. The power. So dishwasher. Oh, Lord. But anyway, you're supposed to be able to freeze the frame. It's supposed to be something that people who can't see could be able to walk around a room and not crash into things, but I got a bad feeling this is not going to go well. So anyway, so it's all dependent on the data and the model, folks. It's not, but great implementation, crap data, right? So anyway, so that's what I wanted to show you, those two demos. Watch the TensorFlow Lite repo for new and hot things. They just did the summit, so it's going to start moving quick, I hope. And lots of goodies coming soon. So thank you so much.